So I'm excited to be here. This is my first time in Dubai, so tremendously excited to be here. I think it's a great place. So I'm here to talk about the role of AI, and I think just getting all the gadgets together. Yeah, thank you. That's terrific. So just a little bit about me. So I think I have an academic background in computational neuroscience. So I got a degree, a master's at Yale University in neuroscience. In 1995, I participated in the first wave of the internet with the Java programming language. So I was part of the Java programming language team as a technical evangelist. I've been 25 plus years in Silicon Valley. I've been a limited partner with a venture firm called Focus Ventures with about 9 IPOs and 44 M&A exits. Recently joined Pantera Capital as limited partner, and I'm also an advisor to 14 different ICOs, as well as founder of an exchange called Evercoin. And my most recent venture is to set up a Japan crypto investment fund called Gumi. So, if you're interested in Japan and crypto investment, please speak with me. So, my journey into computational neuroscience begins here with this organism. Does anybody know what this organism is? It is Aplysia californica, or the sea hare. This is the ultimate neuroscience organism. If you look right in the center of the organism, you're going to see an orange dot. This orange section here is the abdominal ganglia. This organism is about the size of a shoe, and you can actually see that you can pull the organism apart without cutting. And when you pull the organism, you open it, you're going to see this orange dot, which contains about 450 neurons. And the neurons are up to 1 millimeter in size. This abdominal ganglion makes this the perfect organism to understand brains. And in fact, that's exactly what happened. This is Dr. Eric Kandel, and he created a thesis around the L7 neuron. This picture is the abdominal ganglion of this organism, and he actually created an experiment where you tickle the organism and you record the organism's process of learning. So this organism is learning that when it's being tickled, that no threat is coming. And it performs this function called habituation, which is it learns that tickling doesn't mean anything bad. And in fact, he created this entire thesis around this so-called L7 neuron, which means that he was able to win the Nobel Prize. So, wonderful achievement in understanding how the brain learns. So, one of my professors at Yale University also studied this organism, a gentleman by the name of Dr. Larry Cohen. Dr. Cohen had a completely different mindset, which is his mindset was, I understand the L7 neuron is learning. What else is happening in the abdominal ganglion? So his approach was, inject a electrophotosensitive dye into the ganglion so that every time a neuron fires, it shoots out rays of light. So this dye creates almost like a pinball machine in the abdominal ganglion. You can put a photosensor array, a CCD array, and you can detect which neurons are firing during the gill withdrawal reflex of neuronal habituation. And what is the result? This is the result. And what you can see is this is the stimulation event, and these are various neurons, and these are the action potentials in those neurons. What does this result mean? The result means that it's crazily complicated. It's way, way, way more complicated than Eric Kandel suggested. So this is craziness. And what happened with this is he essentially just blew up all of the research on this extremely simple model of a brain. And in fact, when we look at the human brain, it's exceedingly more complex. This is an image of the functional connectome of the default mode network. And the default mode network is basically the network that interconnects different regions of the brain. And when you look at the human brain, people call the brain an organ. Like Woody Allen says the brain is his second favorite organ. But it is a misnomer. The brain, calling the brain an organ is like calling the guts an organ. The brain is a multi-organ system. All of the anatomical regions of the brain, the hippocampus, prefrontal cortex, insular cortex, amygdala, hippocampus, midbrain, thalamus, hypothalamus, all the anatomical sections have their functions, right? And the functions, as you look in the default mode network, are all densely interconnected. So when you see these very large regions like prefrontal cortex, this mapping attempt doesn't even attempt to look at what's happening within each functional zone. This is across functional zones. So if we're unable to understand the simplest organism, how are we to understand the human brain? This is a big, deep challenge. So now, enter blockchain. So my open question to you is this a good investment? So I've gotten some wonderful answers. Some of the shouted answers from audiences around the world are, depends when you got in. The other answer that's been shouted that I really love is, depends when you got out. These are great answers. I'll tell you, the punchline here is, this is not a good investment. This is Lehman Brothers. And of course, we know what happened to Lehman Brothers in September of 2008, which is what I call the Humpty Dumpty moment for the economy as we know it. And it's basically kind of in an irreversible state. And the question is, will the United States have another financial crisis of this size? Bill Gates says it is a certainty. So we're talking about this concept of collapse. And collapse is an inherent mindset. And in fact, we're in a period of unprecedented instability. So when you think about this notion of social instability, all of these things relate to complexity theory because each of these system nodes interacts with all the other system nodes. So energy instability, geopolitical instability, biological instability, energy, everything. All these systems are deeply, deeply interconnected. So what does that bring us to? So it brings us to this concept of collapse. So I wanted to start with just a metaphor. So imagine that you're standing in a high place, like this person. And imagine that you're standing on a thin rail. Now, watch this second foot. Imagine what percentage of weight is on the second foot. What is that percentage? Probably not 50%, right? Probably less than 50% of the weight, maybe 20%, maybe 1% of the weight. But the reason why I'm showing this image is I wanted to talk about the concept of balance, because we're talking about a beam, which is the traditional economy, which is known to collapse. And what we've seen is the emergence of a new beam, which is the crypto economy. So the question is, if you're trying to move from this beam to the new beam, what's the behavior? So people tell me that Bitcoin is tulips. If it's tulips, the graph of the value of Bitcoin should be going to infinity, crashing to zero, and staying at zero forever, right? But it is not what you're seeing. What you're seeing is you're seeing it go up, then you're seeing it crash, then you're seeing it go higher. then you're seeing it crash, and then you're seeing it go higher. What is that? What is that behavior? That behavior is a person testing this new beam and balancing their weight. So they put their weight on the beam, then they take it off the beam, right? And if you're doing a test of a store of value, you should consider that the test includes putting value in and taking it out. So what we're seeing is that's the pattern that we're seeing. But the question then becomes, what is the mechanism we can use to understand collapse? And I think that this has been well understood. If I can impart any mindset today, I'd love to impart the mindset of complex systems theory or complexity or chaos theory. Right? So this is all well characterized, and there's a researcher by the name of Per Bach who created a model called the sand pile. And in the sand pile model, we just continuously pile sand, and what you find is you find that you have a power law distribution of collapses. So you're going to have an inevitable large collapse, and you're going to have many, many small collapses of different sizes. This is just an emergent property of a sand pile. And I want to say that the sand pile models many things, including the collapses in the economy. But it turns out that the sand pile model also applies to things like people's mental stability. It's quite an interesting thing. So there's a lot of neural network research associated with this concept of self-organized criticality. So let's bring it back into the world of blockchain. So this is Dorian Satoshi Nakamoto. And Satoshi Nakamoto, the real one, created open source peer-to-peer, and I inject the word programmable money. And one of the key lessons that gets very underplayed is this notion that what you're creating in this is you're creating an incentivization model. So it's super important to think about is one of the biggest insights that's available in Bitcoin, which is largely poorly understood, is that the programmable money of Bitcoin is an incentivization model that eliminates economic free riding through cryptography, but it also incentivizes good actors in the network to secure the network through things like mining rewards. So the thing that I think is really interesting about it is we're moving into a world of programmable money. The question becomes, what are the programs? And this is where we start to see the interface between AI and blockchain, which is what percentage of the programs that execute in the world of programmable money will be generated by machines, and what percentage of those programs will be generated by humans, right? And that's really interesting to contemplate, right? Because what you're imagining is within this Cambrian explosion of ICOs, $6.5 billion talent grab, there are dormant thousands of projects that could potentially traction. And the reason why traction is important is really because we're talking about exponential technologies. So I'll speak to that in a moment. But I think that there's a deep misunderstanding of the blockchain, which is I think people look at blockchain technologies as databases. And I can tell you that the Bitcoin blockchain is probably one of the worst databases that I've ever seen. It's awful. It's a terrible database. Why is it terrible? It's terrible because it burns electricity, and it's terrible because it's exceedingly slow. So you have to ask yourself, if you're looking for a database, why would you use such a terrible database? And the answer is, you wouldn't. You would never use it for a database because it's terrible at being a database. So why would you use it? Very simple answer. You would use this because you don't trust anyone. That's why you would use this, because every node receives messages about the state of the network. When they receive the message, the immediate response of the node is, this isn't what happened. It's only after receiving confirmations through proof of work that make it economically and thermodynamically impossible to lie to this network. That is astonishing, right? That's a huge achievement, and it's slightly annoying that people are referring to their new infrastructures as second-generation blockchains and claiming to be smarter than Satoshi by simply playing with centralization. I just think that's a bad behavior. It's intellectually dishonest, so I won't go deep there because I don't have very much time. But I do want to say this, which is blockchain is not a database. It is a new mechanism for establishing trust. And it's a mechanism that enables third-party trustlessness. So the question becomes, if you smash together two of the largest trends, AI and blockchain, are you creating heaven or hell? And I can tell you my own personal experience, which is I used to be an AI investor. I had a seed stage investment fund called Seed ML, and I actually participated in this kind of like first wave AI spring. And one of the things that I saw in terms of the talent war is most of the best engine builders in AI are already sitting in big companies, right? So to me, I've moved in my investment thesis from AI to blockchain, and I haven't looked back. And in fact, the intersection of AI and blockchain, I've yet to find a single company that I believe has a worthwhile investment for me. So that's my concern. One of the things that I see a ton of is algorithmic trading. I was actually an advisor to Sentient Systems, which is a company that raised $100 million in a Series C as a startup. And the reason they were able to raise that money is that they actually had created artificially intelligent traders, which trade not cryptocurrencies, but public equities, using evolutionary algorithms that were generating actually real alpha. So they had a money printing machine in their basement, and they were basically able to raise whatever. Fantastic company, probably one of the few kind of early first wave AI spring companies that actually got major traction and remained independent, because most of those companies were acqui-hired at $2 million a head. And those people are all locked up. So when you look at this intersection of AI and blockchain, this is the quote that comes to my mind, which is, this is a quote from HAL 9000 from 2001 Space Odyssey. I'm completely operational and all my circuits are functioning perfectly. So this quote comes in the context of what people think of as machine insanity, which is, if you remember the movie HAL 9000, there's a gentleman, Dave, who's trapped inside of a space station run by an artificial intelligence, and this intelligence is being exceedingly dangerously recalcitrant. And it's open the pod bay doors, and HAL is refusing to do that. But the thing that's funny is HAL is correct. All of HAL's circuits are functioning perfectly. It's just about incentives. HAL is not insane. HAL is incentivized to lock Dave out of the pod. Simple. Incentivization. And the question becomes, well, are all HAL circuits functioning perfectly? It's a little hard to say. What is this? This is a graph of system calls within Windows Server. Now, if you think about how complicated Windows Server is, it's actually not that complicated. But it looks like this. Now what you have to imagine is what something much bigger could look like, and you begin to get very queasy. Because really, the human mind is very limited in its ability to model. And so what you have to look at is, when you look at an AI marketplace filled with AI bots that are maximizing their alpha, you're creating essentially a sand pile. And when you see alpha maximizing bots, you're going to see them creating situations like credit default swaps. They're going to create mechanisms that allow them to pile the sand very high and very deep. Some people say, what does PhD stand for? It stands for pile it higher and deeper. So what does that mean? So here's the interesting bit. The interesting bit is that AI is essentially an exponential technology, and the way you could conceptualize it is in the context of business process improvement, right? So you could see it as a business process improvement. If I were to invest in AI at this time with blockchain, I would look for thinly sliced, fresh application-based data that's very narrow, and I would look for that data to form a positive feedback loop. So what you do is you collect more users, the users create the data, then you take the data and you use the data to improve the service, which then allows you to collect more users, which allows you to collect more data, that's like that. So I'd be looking for something like an Uber. I'd be looking for things that are just clean, fresh, narrow. I would not be looking for big data swamps against which I can do AGI. Doesn't feel investable. And there's a bit of a risk here. I don't want to particularly cap on any specific organization, but this chart is Ray Kurzweil. And the thing that, to me, is disingenuous about this chart is this data point here, right? Which is computers surpassing the brain power of a human in 2023, right? To me, this is intellectually dishonest. The reason why I believe this is intellectually dishonest is that what is the benchmark? If you want to say a computer exceeds the human power against the benchmark of factoring prime numbers that was achieved in 1940s, right? The question is, what is the benchmark? So I feel like this is